Welcome back to the Python Made Easy series. This is the first in a series of classes on Python functions. In this class, we'll cover what they are, why do we use them, we'll define all their parts and pieces and what their composition is, how do they work, and we'll see examples of them in flight to drive it all home. A Python function is a packaged procedure invoked by name. In other words, it's a mechanism by which statements can be grouped together so they can be used more than once in a program. Functions are the alternative to cutting and pasting. They are the most basic structure for code reuse. They make coding more efficient, not just in the cutting and pasting, but if any of the statements within the functions need to be modified, we're changing it once rather than changing it several times in every part and piece of the code that we would use it. They enable us to split complex systems into manageable parts. Functions are created to meet a coding requirement, and then functions are called so that that code may be used. There are two ways to make a function, either through a def statement, DEF, which is short for define, or a lambda expression. This is a nameless function not intended to be used for more complex requirements. To use a function, it must be called by a caller. Each call to a function generates a new local scope that is assigned names, are local, that is only known to the function by default. However, we'll see that there are two ways to manage scope visibility, either locally or globally. Two ways to send results back to callers are through the return statement. This signifies the exit or end of a function and returns a value when called, or a yield statement, which returns a generator object. I'd like to point out that if you've been with me through this whole Python Made Easy series so far, we've already seen many built-in functions. For instance, we've seen the open function for opening a file for reading or writing. We've also seen the len function, which returns the number of items in a collection. The functions we define will operate in a very similar way. And here we'll review some of the main concepts behind Python functions. The def statement. Def is an executable. Until Python reaches and returns the def statement, your function does not exist. Def creates a new function object and assigns it a name. The function name is a reference to the function object. Function names can be stored in a list and assigned to other names. Functions may also be created with a lambda expression, an inline function definition. A def statement would not work in this particular application. The return statement sends a result object back to the caller. When the caller calls the function, it stops until the function is done completing its work. Once that happens, control is handed back to the caller. The return value is the result of the function call. Returns will not always have a value. They can be set to none. Yield sends a result back to the caller, but remembers where it left off. It suspends its state so it may resume later to produce a series of results over time. Coding a function in a module file means it can be imported and reused by any program you run on your computer. We'll continue with some of the main concepts behind Python functions. Variable names are always looked up in scopes. Scopes are places where variables are stored. Assignments bind names to scopes. Arguments are passed by assignment, object reference. They're passed by position, left to right. They may also be passed by key name, name equals value. They return values. Variables are not declared as a specific data type, for instance. There are no type constraints on functions. A single function can often be applied to a variety of object types. Any objects that support a compatible interface, methods and expressions, will do regardless of their specific types. Here we'll get into the def statement and the basic syntax for Python functions. The def statement creates the function and assigns its name, as we have said before. The format is typically def, and then the user-defined function name in lowercase, and then one or more parameters. Then we have the body of the function with one or more statements, and finally the return. So let's go through these. The function header includes the def statement. It's that whole first line. The function parameters are names in the header that are assigned to objects passed in via parentheses when that function is called by a caller. In other words, they represent the values passed in when called. The function's body is the code that gets executed each time the function is called. And the return statement can show up anywhere in the function's body. When it's reached, it ends the function call and sends results and control back to the caller. Return may include an optional object value expression that gives the function results. If no object is specified after the return statement, the return sends back none. In fact, the return statement itself is optional too. What happens in this case is when the last statement of the body is executed, the function exits. Either way, in this case, it will return none too. It is ignored at call time. Just a bit more about the def statement. All we have in Python is runtime. There is no separate compile time because def is a statement that executes at runtime. It can appear anywhere a statement can legally appear in Python, even nested in other statements. An example is inside of an if statement, thereby selecting between two different choices. Defs are not evaluated and run until they are reached and run. And the code inside defs is not evaluated until the functions are called. Functions are just plain objects like everything else in Python. They are recorded explicitly in memory at program execution time. Okay, now that we have laid all the requisite groundwork, let's jump right into some examples about functions in Python. So here, upper left-hand corner, we have a function that we've defined. Def times x comma y. Def stands for a defined statement. Times is what we're calling our function, user defined by convention lowercase, and it has two parameters, x and y respectively. So that whole first statement is known as the header. Then we have a colon. Then we have a return statement. And what are we returning? The product of x and y. Finally, we have a print statement in which we pass it times our function, and then we give two arguments to represent our two parameters, 35 and 40. So when Python reaches and runs this def, it creates a new function object that packages the function's code and assigns the object the name times. Typically, such a statement is coded in a module file and run when the enclosing file is imported, but it doesn't have to be that way. The def statement makes the function, but it does not call the function. Nothing happens here until we reach the caller. Remember, arguments are passed by assignment. So x is assigned the first value we pass in, 35, and y is the second value, 40. We can also assign this call to a variable name to use it later. So we could do something like myfunc equals times and then pass it our two values, whatever they may be, in this case 35 and 40, and then we can print func, we get the same result. Now here we change our first value to boo. Rather than a number, it's a string. Functions are typeless. Python leaves it entirely up to the object to do something reasonable with the syntax. In fact, the asterisk is just a dispatch mechanism that routes control to the objects being processed. This type-dependent type of behavior is called polymorphism. It means that the meaning of an operation depends on the objects being operated on. A single function can be applied to a host of objects as long as the objects support the expected interface or protocol. In other words, they have to have methods and expression operators that are compatible with the function. And here's a slightly more involved example of a function. So this is a function that will tell us what items two sequences have in common. We have defined it with the name of intersect, and it takes two parameters, seq1 and seq2, for sequence 1 and sequence 2. Res, res here, is a list, a local variable, a name that is visible only to the code inside the function definition, and that exists only while the function runs. The same is true for seq1, seq2, and further x, which is inside the body of the for loop. Function variables won't remember values between function calls. For x in sequence 1 or sequence, so it says scan sequence 1, traverse that sequence. And then if x, for each item you scan, if that is also in sequence 2, append that item to our empty list res, then return res. And again, up until this point, nothing happens because this function has not been called. So the next thing that has to happen is we have to have some way of calling this function. We do this via this print statement right here. So print intersect the name of our function, and now we have to pass it 2 arguments to correspond to the 2 parameters that were set in the header of our function definition. We decide to define 2 strings, pizza and piazza. So our algorithm is for every item in the first argument, if that item is also in the second argument, append that to the result list. That is the algorithm. So what happens with our output in this particular case? You see in the right-hand side, result finds the objects in common, and it's P-I-Z-Z-A. The only requirement for the objects to work as arguments is the first one has to support a for loop. The second argument has to support the in-membership test, right? Because the first one is sequence 1, and that's being used in our for loop. The second one, sequence 2, is being used in our if statement. So that has to support the in-membership test. We can use our functions again with different types of data. Here we use it with a list and also a tuple, but it doesn't matter. They still both will work and meet the requirements of what we just laid out. That means the first one, the list, has to support a for loop, so it has to be an iterable, check it is. And the second has to support the in-membership test, and a tuple does that. So the results are the same. It's a list. Why is it a list? Because res is a list, and we're printing out res. That's why it outputs as a list, and it finds the 2 elements in common, 2 and 3. Note, in practice, there's a more efficient way to do this. Nested loops are not the most efficient thing. So a better way to do this is to use list comprehension. And I give you the example. We've covered list comprehension in lists and also in our iterable module, or iterator module rather. So we have S1 stan, S2 man, X for X in S1, if X in S2, and it finds A and N as the 2 elements in common. If that confuses you at all, I invite you to go back to the list class and also to the iterator class in this series. Folks, if this training class has helped you, please consider helping me if you feel moved to do so. And you can do that by subscribing to the page, liking this video, and sharing it with your friends who may be in need. I'm trying to help as many people as I can in ways that I have been helped.